Good morning. I wanted to do a couple of the harder problems with you. And so from your homework, number 12, sine of x times tangent of x plus cotangent of x, I wanted to do that one with you guys. So here we go. So there's a couple of things that you could do first. And so like this says here at the bottom, there are many ways to verify trig equations, and you just have to find the way that works the best for you. And so I'm going to show you what I like to do in these types of problems, and you can decide to do it this way or you can try it another way. And so first things first, I like to change everything to sine and cosine. And so that would make this sine of x times sine of x over cosine of x plus cosine of x over sine of x. And so you may see pretty quickly that this can start to look pretty complicated with lots of fractions. And so embrace the fractions. You can do it, I promise. And so we have some fractions happening here, and then we have sine on the outside. And so one thing that you need to remember is the sine is over 1. And so when we distribute this, because we have some multiplication that could happen here, remember from our list that that is one of the options, like change everything to sine and cosine, multiply things out. And so sine times sine would give us sine squared of x, still over cosine, plus sine of x cosine of x, so they just get put next to each other, over sine of x. And hopefully you see that there's a sine on top and a sine on bottom, and those things can get divided out. And so we end up with sine squared over cosine, just one cosine, plus cosine now over 1. And so remember when we talked yesterday that the denominators need to be the same on our fractions in order for us to add. And so just like we multiplied on that one yesterday, the numerator and the denominator times 2, I believe. Let me look from that warm-up question. Yeah, so this one we multiplied 2 over 2 to give our denominator to match our denominator, so that the new denominator is 4. And so we're doing the same thing with this one, except I want my denominator to be cosine. And so I have to multiply the top and the bottom by the same thing. And so this is going to turn the top into cosine squared of x. And so now that I have the same denominators, I can add the tops together. Sine squared of x plus cosine squared of x over cosine of x. And so one of the rules from our list was add or subtract fractions, and so that's exactly what I did here. I've added or subtracted fractions, I've multiplied, I've put everything in terms of sine and cosine, and now, big red flag, we have some squared terms, and so that might be really helpful for us in this next step. And so here we have, it's kind of tiny, but we have cosine squared plus sine squared is equal to 1, or sine squared plus cosine squared, that's going to equal 1 over cosine. And so the nice thing about those squared terms is they can turn into 1 pretty quickly. And so if you aren't paying attention to those squared terms, your Pythagorean identities are very helpful here. And then we have 1 over cosine, and 1 over cosine is equal to secant. And if you look at the answers on the back, it should, those match. Okay, so that's one question that was pretty challenging for us. And then another one that I'm going to do, this one I believe is number 3 on today's homework. So if you would go ahead and pass out today's homework, and that way I can kind of show you how today's homework is working. And so I've given you the answers on the front. So like this left side of the equation is equal to the right side of the equation. And so what we're doing is like, we can kind of ignore this for now, and my final answer should end up, once I've simplified everything, should end up as cosine plus sine. And so we're just verifying that this side of the equation is equal to this side of the equation. So we're going to show all of our work to get there, and it's just all together. So it's just another way of writing how this problem looks. And so it's a way of me giving you where you're headed when it's not quite as obvious where you might be headed. Okay, so we have secant squared minus tangent squared plus tangent all over secant. And so in this case, it's pretty complicated. And so I want to look for a way to make this less complicated as quickly as possible. And so, big red flag, we have some squared terms, we have some squared terms. And so on your paper, you have the identity secant squared is equal to 1 plus tangent squared. That's the identity that you have. And so what I want you to think about is there a way for me to rearrange this equation using algebra, moving things from one side to the other, to make it look like secant squared of x minus tangent squared of x? And so hopefully you see that if I move this to the other side, I end up with secant squared of x. So hopefully you see when I move this to the other side, I end up with secant squared of x minus tangent squared of x is equal to 1, which is going to make our equation much simpler very quickly. And so that's the goal always, is can I make this simpler than it is right now? And so secant squared minus tangent squared is now 1 plus tangent of x all over secant of x. And so one thing that is helpful, like it's already simpler, and I'm going to go back to our list here. And so let's clear this so that we're starting fresh. So we've done this, but what I haven't tried yet, we haven't talked about this in anything that I've shown you, we can split one fraction into two fractions. And so let me show you what that looks like. And so what we can do next is we can split this fraction into two pieces. And so I end up with 1 over secant of x plus tangent of x over secant of x. And so we know that 1 over secant of x from our identities is actually equal to cosine of x. And then this one gets a little bit complicated, and so we want to change everything to sine and cosine. And so tangent is going to equal sine of x over cosine of x. And secant is going to equal 1 over cosine of x. And so just like we simplified our fractions with our unit circle, we can simplify the cosines because both denominators are both cosine here. And so we end up with cosine of x plus sine of x, which is the answer that we were trying to get to originally. I hope that helps.